So first of all, thank you all for joining this morning session. And I present myself. I'm Federico Ferrari. I work in Carel in marketing unit food retail, and I'm an application specialist for condensing unit and compressor racks. So today's presentation will be about natural refrigerant, especially an application that was a little bit outside our normal field of operation. In fact, we will see it's been a marine installation. But let's start with a little bit of context about the current panorama. It's something we all already know about the growing marketing trends for natural refrigerant. These are the numbers collected by Atmosphere, which shows the panorama for CO2 installation around the world. Of course, you will see many installations in Europe, but other countries are following in these growing trends. And here is how Carel is supporting this evolution towards a more sustainable refrigeration. These numbers are mainly referred to commercial refrigeration, but as we'll see, these can be enlarged to other topics. Just to give you a reference, these are about propane and CO2, and splitted by our high efficiency solutions, as well as our standard CO2 compressor racks. Carel offers several different solutions running with natural refrigerant, and here we see the main ones. So we have HECU, the high efficiency condensing units, available with HFC, but also with CO2 in transcritical mode. We have also our standard controller for compressor racks, which is PRAC CO2. EOS, our solution for plug-in and semi-plug-in systems, and this is available for propane and also CO2. And PR multi-DC, which maybe is our most complex solution, and it's running with CO2 only. We will be talking about this last solution, the PR multi-DC, especially about a new application, because as you see in the title, it can be used from commercial refrigeration, but also to new application. In this case, marine equipment. This was a peculiar project because we were contacted by Bicul, a contractor that produce also units for marine application, from HVAC to refrigeration and other technological system for ships. Let's start to give a little bit of context about the solution itself. So PR multi-DC is our most innovative solution in refrigeration because it includes all our technologies, from BLDC compressors to electronic expansion valve, all controlled by our PRAC controller and probes and inverters. So it can reach up to 45 kilowatt in medium temperature and up to 10 kilowatt in low temperature, combining up to 6 compressors on the medium temperature line and up to 2 in the low temperature line. Since all the compressors are a variable speed, it can reach a very wide modulation from like 5% of the installed capacity up to 100%. It's a compact solution with a footprint that can, in this example of layout, it can reach the form factor of 2 meters of height and a Euro pallet of footprint. So it's very compact and very used in retrofits. The core of this solution is the DC inverter technology, which Carel has adopted, and together with Toshiba, we developed a lineup of compressors for CO2, which is available in 4 sizes, and it's very efficient compared to AC piston compressor due to its very wide modulation range. It consumes less energy because it's a permanent magnet rotor, and it doesn't need to be magnetized. And since of its wide modulation range, it reduced a lot the on-off cycles. It's combined with our Power Plus range, which is not a simple inverter. In fact, it embeds also a software that controls the envelope. As you see, there is a control to stay inside the envelope of the compressor given by the manufacturer, Toshiba. And also it saves additional electrical components for safeties. Due to its very wide modulation range, it can reach low speed, of course, and that's a little bit of a problem in terms of oil management. Because of this, we have a patented technology we develop internally in our R&D department. It's a patent pending system, which is quite smart in my opinion, and I invite you to check our compressor in our stand, where you can see this valve right here. And the purpose is quite complex, because the pipe, called the balance pipe, is placed at the right oil level that the compressor should maintain to work properly. And periodically, we open the valve, the oil check valve, and check if there is a temperature drop at the inlet, between the inlet and the outlet. If there is not, all good, and it means that the oil is flowing. That's also useful to balance the oil level between all the compressor in the line. If there is a temperature drop, it means that refrigerant is passing through, it's expanding, and that's a problem because there is no oil at the right level, and it means that we need to do an oil injection. This oil system was one of the many reasons, together of the compact form factor and the fact that Carel was providing the whole solution with all components, that made Bicul opting for Carel as a partner for this project. As we see here, we provide all the components, from the controllers to the compressor, the inverter, the electronic expansion valve, and very interesting, the supervisory system, which was a key in the commissioning and to fine-tune the system and all the parameters. Also, there is the option to have a fully assembled electronic panel. That means that other than the mechanical part, everything comes to the factory in a whole piece. Okay, here we come to the installation. The installation was made in Denmark in April 2022. This was the result of many tests from Bicul, which tested the unit for like a year to fine-tune all the mechanical circuit, especially the oil, and also to check if the unit was properly designed to resist to the continuous motive of the ship. So it was tested at different slopes and angles of installation. As I mentioned, it was built in a compact factor, that is the installation in the ships, where the space are, of course, as you can imagine, very reduced. There was a full Carel support on field. We had technical from our subsidiary in Carel Nordic in Denmark, as well as the support from headquarters, made possible by the supervisory system. And the Boss Mini that we used also to monitor the system when the ship is in the harbor, as well as, hopefully not, there could be problem when the ship is in the middle of the sea. We can check the situation and eventually provide support. The system itself is made by 2 units because of a complete redundancy opted by the contractor. In this way, everything is doubled, literally. So even in the cell, which is the cold room of the kitchen of the ships, we have a double evaporator, which are working one or the other according to the compressor rack that is up and running. Both compressor racks are made by low temperature line and a medium temperature line in a booster configuration. The installed cooling capacity, well, the required one was 1.6 kilowatt in medium temperature and 3.5 kilowatt in low temperature. Then the compressors are quite oversized and they can provide a bigger capacity. But it's an additional redundancy asked by the contractor, and the fact that you don't really want to provide a compressor change when the ship is in the middle of the sea. So the redundancy was a big topic here. An interesting thing is that the gas cooler is cooled by a water loop present in the boat that is used for to cool all the to cool also the motor of the ship, and it's cooled itself by the water of the sea. That means that the temperature changes a lot according to the geographical position of the boat. But since the ship is currently sailing in the Northern Sea, that means the unit is working mostly in subcritical condition that raise the efficiency even more. Of course, it will work in transcritical condition when the ship will be more in a tropical region. Efficiency, together with the redundancy, it's a big topic here, because in this particular sector of the marine equipment, it's okay to spend a little bit more to increase the investment, because the return on investment is quite big because of the cost of electricity, of energy on board. The energy comes from the motor of the ships, and so it's quite expensive. It's made by burning oil, in fact. That's why BeCool opted for such a system. As mentioned, another big topic for this unit is the supervision, which is a strong point from Karel, since we provide a supervisory system as well as a cloud platform where we can collect the data, analyze them, and provide assistance. We are still collecting the data to check the system, but the remote connection, usually, if nothing goes wrong, it's available only when the ship is in the harbor. So we collect data mostly when the ship is stopped in the harbor. Otherwise, we can connect to the system when there is need of assistance. And for sure, it was a key point during commissioning, where we monitor how the compressor were running, especially the oil system, even if no troubles were showing up since the unit was being deeply tested in a BeCool factory. So this is a kind of strange new application for multi-DC, which was born to cover commercial refrigeration systems. But this open the doors for a new application. And I invite you to our booth to check. We can talk more about the oil system, as well as showing you the compressor, and also the other high efficiency solution running with BLDC and electronic expansion valve. So this was all from my side. I invite you also to visit natref.karel.com, which is our website where we collect all the information about our high efficiency solutions. And thanks for attending. And if you have a question, please feel free to ask.
What's the maximum temperature of the water loop circus for gas cooling?
Well, the system is usually designed to work in transcritical condition. In this particular case, the limits are probably related to the sizing of the gas cooler itself. I'm not really aware of what condition BeCool chose to be the maximum, because I'm not also really an expert of the water temperature that can reach, but I guess that in tropical condition it can goes up, I don't know, 25, 30 degrees, no more, because in the end it's cooled by the water. But yeah, more or less, it's all depending on the gas cooler design and sizing. It was an exception in this case to have a water-cooled gas cooler. Usually we cooled in the air. It's an air-cooled gas cooler. Excuse me? The water in the sea? Okay, so I guess it was considered. I don't know really, actually. but it can work in transcritical, so we are not very afraid by the transcritical working. It's all about the gas cooler design, so it was more on the mechanical side. But if you want, I can collect more information about this and we can talk in our stand. Okay, if there are no other questions, I thank you for attending and enjoy the rest of your day. Thank you very much.